All right, today we're diving into a system for decentralized computation that claims to do something that sounds, well, pretty much impossible. It aims to get perfect agreement between computers without them ever having to vote or reach a consensus. It's called the Tetragrammatron.
So let's kick things off with a little puzzle. Picture this. You've got two computers, Node A and Node B. They're completely separate, totally isolated from each other. And we give both of them the exact same simple piece of information. Okay, and here is the crazy part. Without communicating, no network connection, no nothing. They both independently process that input and they spit out the exact same output. I mean, not just similar, but bit for bit identical. The same unique ID, this SID, and even the same unique IPv6 network address. Right? How on earth is that possible? I mean, in any normal system, you'd need a shared database, some complex consensus algorithm, something to keep them in sync. But there's none of that here. So, what's the trick?
Well, the secret isn't about what data they share, because they don't share any. It's all about the process they share. The entire system is built on a shared set of rules, a shared calculus, not a shared blob of data. And this quote right here, it just nails it. Instead of nodes needing to agree on some central record of truth, they just have to agree on the rules for processing information. If everyone is playing by the same rulebook, they're all going to arrive at the same truth all on their own. And that shared rulebook has a name, the Deterministic Blackboard Calculus, or DBC for short. You can kind of think of it like this universal machine for refining information. Its whole job is to take any input you give it and, through a series of steps, boil it down into one single universally understood normal form. Now, this refinement process isn't just some free-for-all. Nope. It's a super strict 4-stage pipeline. Every single piece of info has to go through these exact 4 steps in this exact order. So first, the input gets realized. Basically, it's put into a formal, structured format. Then it's closed, which is where the system figures out all the hidden connections and logical consequences. Next up, it's normalized, and this is key. It collapses anything that means the same thing into one single official version. And finally, that one true form is projected for us to see, but only as a read-only view. Yeah, that normal form is everything. It's the canonical source of truth. The system guarantees that if two different inputs actually have the same meaning, they literally become the same object. There's no room for ambiguity. It's one meaning, one form, period.
Okay, so you might be thinking, this sounds cool, but how do we actually trust it? Well, the beauty of it is, it's not based on trust. It's built on a foundation of provable, totally unbreakable mathematical laws. The DBC itself is locked down by these core laws. The big one is confluence. This law guarantees that no matter how you process the data, you always end up at the exact same normal form. It's like all roads lead to Rome. Then you have other laws that make sure the system can't just invent new stuff or change its mind after it's done. Now, this whole calculus engine has to live somewhere, right? It runs on top of an equally solid foundation for storage. It's called the Native Repository Runtime, or NRR. This is like the digital bedrock that the whole house is built on. And you guessed it, the NRR has its own set of unbreakable laws. The content address law is simple. An object's address is just a cryptographic fingerprint of what's inside it. The append-only law means you can add to history, but you can never change or delete the past. And the replay law is huge. It means anyone, anywhere, can perfectly rebuild the entire history of the system, bit for bit. So let's put it all together. You've got this super predictable calculus sitting on top of this unchangeable, verifiable storage layer. When you combine those two things, you completely change the game for how networks and digital identity can be built. And this is the big idea, the real mind bender. Traditional networks are all about arguing and agreeing on a shared state, a central database or a blockchain ledger. This system flips that on its head. Here, nobody has to agree on the state. They just have to agree on the calculus, the rules of the game. If everyone runs the same rulebook, they all get the same answers. No coordination needed. And this thinking leads to this really clean, full-stack architecture. Down at the bottom, you have the substrate. That's your immutable NRR storage. On top of that, the protocol layer uses DBC to find the canonical meaning of everything. Then the core is the engine that actually runs the calculations. And way up at the top, the hub, that's just a read-only window, a GUI, to look at the final settled truth.
And this really hammers home that one-way flow of truth. The user interface is literally just a projection surface, like a movie screen. You can observe the canonical truth the system figures out, but you have absolutely no power to author it or change it. It's a brilliant separation of concerns.
Okay, so let's circle all the way back to that little magic trick we started with. Why does all of this matter? What does this new loop for decentralization actually give us?
What this system creates is this incredibly elegant and powerful loop. It all starts with the true meaning of some data. Once the system calculates that meaning, it uses it to forge a totally unique and verifiable identity. And this is the final piece of the puzzle. That unique identity isn't just a label. It's used to deterministically calculate a network address. And that is exactly how our two separate nodes came up with the same IPv6 address. They followed the same ironclad rules, from the same input to derive the same meaning, which gave them the same identity, which in turn gave them the very same address. No central server, no consensus, no magic, just math.
So this all leaves us with a really big, kind of provocative question to chew on. For decades, we've been trying to solve decentralization by forcing computers to agree on what the data is. But what if we've been asking the wrong question all along? What if the future of the internet isn't built on agreeing what the data is, but on agreeing how to think about it?